In this fifth video, we'll be looking at the angles between two planes. So, if we begin here with two planes, and we imagine viewing from this angle, so that this is our view, we can start to wonder about this angle here, theta, the acute angle between these two planes, and how we could find that angle. Well, first we can do a simple bit of geometry. If this angle is theta, then this angle is 180 minus theta. And then since this shape here is a quadrilateral with 90 degrees here, 90 degrees here, and 180 minus theta here, this must be theta as well. And by vertically opposite angles, this must be theta. Therefore, the angle between the two planes is just the same as the angle between the two normal vectors. And that takes us back to the beginning of the previous video. This is the formula to find the angle between those two vectors, the acute angle. So, find the angle between these two planes. Again, this is given in a very easy way to identify the normal vector, whereas this one isn't. If I give you a moment to figure out from this plane what the normal vector is, and then write this plane in vector form, remembering that these are the unit vectors I, j, k, and maybe you could just pause the video and fill all that information in. Okay, here's what you should have. Now remember, these two vectors are direction vectors inside the plane, or rather parallel to the plane. So to find a vector perpendicular to the plane, you can just find the cross product of these two and fill it in here. I'll give you a moment to do that. Just pause the video. And that's what you should have. I'll let you finish the calculation, but if you find the acute angle between this and this, you'll find it's 42.8 degrees. And this question's far more interesting. Determine the values of k for which this line and this plane are parallel. So you might want to wonder for a moment, if this line is parallel to this plane, what must be true about the direction vector of this line and the normal vector of this line? Well, there's the line rearranged into a more convenient format to read off the direction, which is here, and the normal vector of this plane is here. I'm sure you've figured out by now, if the line is parallel to the plane, then its direction vector must be perpendicular to the normal vector. So I'll leave you to solve that equation for k. Now, one thing you have to remember is written like this, k is not allowed to be 0. So to make it more universal, we could take this as 2k, 1, and minus k in order to allow for the possibility that k is 0. We can't replace k equals 0 here, but we can here. It still gives a plane. So when you calculate this, you may want to write instead here 2k, 1 minus k. And you should get two answers, which I'll leave you to finish and check in the back of the book. But when we animate this, we get this beautiful pirouette, if you like, of the line and the plane. So as we change k, obviously they both change position simultaneously. And you'll find there's actually two places where the line and the plane are parallel. See if you can complete the calculation to show that that's true. Well, that's the end of our videos for today. If I had come into school today, that would have been everything that we would have done on Monday and Tuesday. So you need to try these for homework.